Hello, in this video we will see how to convert NFA to DFA. So here is the NFA given to us. We wish to convert this to DFA. So what we do is we start by calculating epsilon closure of the start state of NFA. The start state of NFA is 0. Now how you calculate epsilon closure of 0? When you are calculating epsilon closure of something, that something is added to the partial result. So since we are calculating epsilon closure of 0, 0 is part of the result. And now we look at the NFA and we see, are there any epsilon transition from state 0? We have an epsilon transition from state 0 to state 1, but we recursively check this whole thing, right? So we check, are there any epsilon transition from 1? So we have epsilon transition to 2 and 4. Then there are no epsilon transition from state 2 and state 4. But we do realize that we have additional epsilon transition from state 0, and that is to state 7. Okay. Now state 7 does not have any epsilon transition from state 7. So we are done with this. Now this will be called as state A. And this A which we have just calculated, right, will be the start state of my DFA. The reason is state A, right, this state A contains state 0, and state 0 is the start state of my NFA. Hence state A would be the start state of DFA. Now we calculate the delta transition on state A. So we wish to know on state A, on input symbol A, where do I go? So for that I'll calculate epsilon closure again, right? So epsilon closure of what? We check in state A, we check transition on input alphabet A. 0A, nothing. 1A, nothing. 2A, 3. So we write 3. 4A, nothing. 7A, 8. Right? So this is epsilon closure of 3, 8. We have to calculate this because we haven't calculated this in the past. So epsilon closure of 3, 8 will contain 3, 8. And then we see the epsilon transition from 3. Now we go to 6. Epsilon transition from 8. No epsilon transition from 6. Epsilon transition takes you to 7. 1. Right? From 7. No epsilon transition. From 1. We have epsilon transition to 2 and 4, right? So this is your epsilon closure. Let's name it as B. Okay. So on input symbol A, from state A, I go to state B. Now why state A and state B are not final states? Because you see in the original NFA, look at this, state 10 is the final state, and state A does not contain 10. State B also does not contain 10. Right? Hence A and B are not final states. Okay. Now we will calculate delta A comma B, which is again epsilon closure of what? State A contains 0, 1, 2, 4, 7. So 0 and on input symbol B. 0B, no transition. 1B, no transition. 2B, no transition. 4B, there is a transition to 5. 7B, there is no transition. Now again we have to calculate this epsilon closure. So how would you do that? You are calculating epsilon closure of 5. So 5 is added to the list, to the output, and then we look out for epsilon transition from 5. 5 epsilon transition takes you to 6, right? From 6 it takes you to 1 and 7. From 1 it takes you to 2 and 4, right? From state 7 no epsilon transition. From state 2 and 4 also no epsilon transition, right? So this would be state C. This would be state C. This means that by reading B on state A, if I read B, I go to state C. State C is also not a final state because final state is 10 and 10 is not part of C. Okay. Likewise, we will continue. We will calculate delta B comma A, which is again epsilon closure of something. Now in state B, we have 3, 8, 6 or 7, 1. You can see this, right? This is in state B. And the input alphabet is A. So let's check that. 3A, no. 8A, no. 6A, no. 7A takes you to 8, right? 1A, no. 2A takes you to 3. 4A, nothing. Now you see, we have already calculated epsilon closure of 8, 3, which is over here, right? And what is the name of it? The name of it is B. So I just rename it as B. So there is a self loop. There is a self loop on input symbol A for state B, right? Now we will calculate delta B comma B, which is also epsilon closure of something. Okay, so let's calculate that. B contains 3867124, as you can see over here, right? On input alphabet B. 3B, no. 8B takes you to 9. 6B, no. 7B, no. 1B, no. 2B, no. 4B, yes, takes you to 5. Right. So epsilon closure of 9, 5, we will calculate it. 9, 5 is added to the result. 9 epsilon, nothing. 5 epsilon takes you to 6. 6 epsilon takes you to 1, 7. 1 takes you to 2 and 4. 7 does not have epsilon transition. 2 and 4 also does not have epsilon transition. So this is a new state now, right? And now this state is D. This state is D. This means that on input symbol B, state capital B, you go to state D. State D is also not a final state because state D does not have 10. And 10 is the final state of our NFA. Okay. So after calculating this, we will calculate it for delta C comma A, right? Which is epsilon closure of what? We will calculate it for epsilon closure of CA. Now, what does C contain? C contains this whole thing, right? C contains this thing. And our input alphabet is A. 5A, no. 6A, no. 1A, no. 7A takes you to 8. 2A takes you to 3. 4A, no. We have already calculated this epsilon closure, and that is B actually. So CA takes you to B. CA takes you to B. Likewise, now we will calculate it for delta C comma B, which is epsilon closure of what? CB. Okay. So C contains this whole thing. 5, 6, 1, 7, 2, 4. Input alphabet is B. 5B, no. 6B, no. 1B, no. 7B, no. 2B, no. 4B takes you to 5. And we have calculated epsilon closure of 5. Epsilon closure of 5 is C, right? So that's C. So for C, we have a self loop on input alphabet B, right? A, this should have been A, right? C A takes you to B, and CB, you have a self loop. Okay. Then we will calculate it for DA, which is epsilon closure of something. So what is that? Now D contains this whole thing, right? Input alphabet is A. 9A, no. 5A, no. 6A, no. 1A, no. 7A takes you to 8. 2a takes you to 3, 4a takes you nowhere. And we have already calculated epsilon closure of 8, 3, which is B. So DA takes you to B, right? DA takes you to B. Let's now figure out what we get for delta D comma B is epsilon closure of something. What is that? DB. Now this is your D and input alphabet is B. 9B takes you to 10. 5B no, 6B no, 1B no, 7B no, 2B no, 4B takes you to 5. And you see we haven't yet calculated this epsilon closure. So we have to calculate it. Epsilon closure of 10, 5 will contain 10, 5. And then we recurse over here for epsilon transition. 10 epsilon no, 5 epsilon takes you to 6. 6 epsilon takes you to 1 and 7. 1 epsilon takes you to 2 and 4. 7, 2 and 4 do not have any epsilon transition, so we are done. And let's name it as E. Let's name it as E. So DB takes you to E. And you see E will be my final state because E contains 10 and 10 is the final state of the given NFA. So DB takes you to E. Okay, now although we have got the final state, we have to still see what will be the A and B transitions for E, right? So delta EA is we have to first calculate, which is epsilon closure of something. What is that? EA. So E contains this whole thing, right? And the input alphabet is A. So we check 10A, no. 5A, no. 6A, no. 1A, no. 7A takes you to 8. 2A takes you to 3. 4A, no transition. And we know what does epsilon closure of 8, 3 is. That's B. Right? So from E on input alphabet A, we go to state B. Okay. Likewise, we will check what is the delta transition on EB, which is again epsilon closure of something. What's that? EB. This is the E, right? 10, 5, 6, 1, 7, 2, 4. And we check for input alphabet B. 10B, no. 5B, no. 6B, no. 1B, no. 7B, no. 2B, no. 4B takes you to 5. And you know what is epsilon closure of 5? Epsilon closure of 5 is C, right? C. C. So by reading B, we go to C. Okay. Now this completes our DFA, right? Unique transition for on every input symbol in every state, right? I hope you have understood this. Thank you.